Hi, my name is Dave Newell. I'm a Business Development Director at Matcon. I've been working in the Asia Pacific region for over 20 years and I'm visiting many plants in many countries in different industries. All have their own unique challenges and requirements. But in today's COVID times, this webinar is very topical. We're looking at optimising production efficiency and their capacity during these challenging times. Hopefully you enjoy the webinar and please leave any questions at the end. Thank you. The presentation topics that we'll cover today include an introduction about Matcon, the challenges of today's manufacturing plants, ingredient formulation, efficient mixing, packing feed, equipment cleaning, and a summary. Matcon are a powder handling system supplier. It was established in 1980 by launching discharge valves for silos, which were predominantly used in the mineral processing industry. The cone valve technology evolved and was applied to intermediate bulk container systems, or IBCs. These were used for batch production in manufacturing plants around the world. In July 2012, Matcon was acquired by the IDEX Corporation, based in the USA. Matcon are the originators of cone valve technology. This technology has been used for a number of years and has a lot of benefits to the manufacturing plant. When we discharge the IBCs, the blend homogeneity is maintained, so there's no segregation. We can also handle free-flowing powders, as well as cohesive materials that tend to bridge and rat hole. We can also handle fragile products, such as tablets and cereals. The IBC system is a contained system, so it has dust-free handling, so there's no risk of cross-contamination. Matcon are part of the IDEX Material Processing Technology Division, or MPT. In that division there are companies in the powder division, which include Matcon, Quadro and Fitzpatrick, and also companies in the liquid division, which include Microfluidics, Quadro and Steridose. Matcon truly is a global company with our headquarters in the UK, also office in USA, and offices in India, China and Singapore. It's important in the Asia Pacific area that we have local support. This is provided by a number of agents as well as Matcon employees throughout the region. And it's the way we've been supporting the region for over 20 years. Matcon has global testing capabilities. The UK test plant, the USA test plant, and the test plant in China and also India. There is also some roadshow units in Thailand, Indonesia and Australia. With our 40+ years of existence, we've gained experience in many industries. A lot of our equipment is designed and is driven by the industry requirements. Most of these industries are shown here. The requirements could be flexibility, throughput, hygiene, containment, the addition of liquids and fats. All are unique to each industry. A breakout of the food and pharma sectors where we have a lot of experience are shown here. They include 3-in-1 beverage applications, infant formula, flavours and fragrances, sports nutrition, the bakery premix industry and the pharmaceutical industry. The challenges for today's manufacturing plants is quite vast. These include increased product variety, driven by consumer demand. There's an increased level of allergens to handle. The batch sizes are becoming smaller and there's more of them. There's shorter lead times driven by the end client. There's an increased labour and material cost. Stricter regulations driven by regulators such as the FDA and also local regulators. And there's a tougher CapEx justification for capital investment. Look at applying lean principles to manufacturing. They'll help us identify areas where we can become more efficient. Lean is defined as to maximise the customer's value whilst minimising waste. The waste are defined by overproduction. This is associated with campaign manufacturing, by producing to stock rather than an order. Waiting time, waiting for a process to be loaded, unloaded and cleaned. Over-processing, using larger equipment than required to produce a smaller batch. Transportation, unnecessary movement of people and the equipment. And producing defects unnecessarily. The biggest cost to the business is the production of too much inventory, which is associated with manufacturing to stock rather than to an order. Some of the essential lean principles include push, not pull manufacturing, so you're manufacturing to an order rather than to stock. Increasing the overall equipment effectiveness, the OEE. Look at flow manufacturing, like one batch being processed, one batch is waiting to be processed. Reducing the takt time, by the time it takes to get from one process to another. Improving the single minute exchange of dye, either changeover time from one recipe to another. Adopting a visual aid, such as a Kanban, in the form of a paper or an automatic system, so that all of the production team are aware of what's being produced when. So what's the solution? The solution is to have a flexible manufacturing plant. So you're manufacturing to an order rather than to stock. You can change recipes quickly, and being agile and flexible will allow you to meet today's challenges. Here we show a video of different processes happening at the same time. Some of the key benefits of the IBC system can be split into operation and financial. The operational benefits include flexibility and agile powder handling, increasing the overall equipment effectiveness, the OEE, optimizing the process time or the takt time, separation and traceability of batches throughout the plant. Financial benefits include quick changeover, allowing to make to order, reducing the need for inventory and work in progress, improving the company's cash flow. And it's a modular investment, so investment could be made now and in the future. The IBC system is a modular system. It grows as your company grows. The IBCs provide the flexibility in the manufacturing plant, and they're using different processes such as formulation, blending, packing feed, and they can be cleaned offline. We'll look at these processes in more detail now. So now we're going to look at ingredient formulation and some of those considerations when we're preparing ingredients for a recipe. Some of the considerations are the production capacity, now and in the future, the number of recipe changeovers, how frequently are they? And it's a good idea to categorize the ingredients into major ingredients, minor ingredients, and also micros, because there'll be no one system that can handle all three. Also the dosing weight and the accuracy required, and put in a realistic accuracy required for the ingredient formulation. Is there any allergens that are to be handled? The number of SKUs, the raw material packaging form, is it 25 kilo bags, is it bulk bags? Also the flowability of the material, is it cohesive, is it free flowing? And I think what we need to do is we need to look at a sensible level of automation that is required now and in the future. So here we're looking at manual addition of the micro ingredients into a batch. On the left we show a manual system through a 3-in-1 sack tip system through a sieve into an IBC, which is dust tight and contained. So it's easy to change over the system from one recipe to another. On the right we have an automatic system for fitting and removal of the lid of the IBC, which is used more in high containment applications. This is an automated micro dosing system called the FlexiBatch Micro. It's suited for ingredient weight ranges of hundreds of grams up to about 10 kilos. It consists of 10 60-litre containers which are mounted in a carousel and automatically rotate round to dose into a bag or a box depending on the recipe. There's a high throughput, we can dose up to 2 dosings per minute, and it also provides very good brand security, so the operators aren't aware of the secret formula that is being produced from the system. Also reduces errors that are associated with manual weighing and can be connected to an MES system. We'll just run a short video on the FlexiBatch Micro now. This is an automated minor ingredient formulation system called the FlexiBatch. It's recipe controlled formulation which can be downloaded from an MES. This will be suited for dosing ingredients in a weight range of say 10 kilos up to several hundred kilos. There's no human error as is associated with manual weighing. It's a quick changeover. The IBCs can change with different ingredients depending on what's being made when. and there's a loss in weight or gaining weight dosing system. Multiple ingredients and recipes can be made at the same time. We could also have batch traceability with connection to an MES system. We'll look at a short video on how the FlexiBatch system works now. So now we're looking at the major ingredient formulation, and they can be automatically dosed from hoppers and silos. So these ingredients could be starch, MSG, salt. These are the high running ingredients that are used a lot in the formulation. It can be automated ingredient batching, so there's no human error. And because we're using the cone valve system for discharging, we have prevention of powder flow issues and mass flow issues, as well as a high degree of accuracy. It can also be connected to an MES system to provide batch traceability. These are examples of a FlexiBatch system. So you've got the ingredient IBCs above, and they can be loaded up, ready for the shift's production, and they can be changed as the recipe changes as well. Underneath we have a weigh platform with a conveyor which moves along and automatically locates the batch IBC underneath the ingredient IBC, ready to be dosed. This is an example of a customer site handling micros, minors, and also major ingredients. The minors and the micros are added in manually at the sack tipping station, and the major ingredients are dosed into the batch container from a number of hoppers and silos. Mixing is the first value added process, and it sets one company apart from another. There are considerations when looking at a mixing process. Considerations are production capacity, the batch size range, ingredient quantities, maximising the OEE, so no waiting time to be loaded and unloaded and cleaning, reducing the time between mixing the previous process and the next process. Are there liquids and oils that need to be added? And what is the process after mixing? Fixed mixers are generally directly coupled to a process above and below. This requires a tall building structure. Recipe changeovers and cleaning take a long time, and they're more suited for campaign manufacturing where making the same product range day in, day out. The disadvantage of a directly coupled mixing system include the downtime, waiting to be loaded and unloaded and cleaned, health and safety issues as you need a very tall structure to load the mixer and position the equipment below it. As we mentioned before, generally leads to high inventory levels, work in progress and finished goods inventory. It's labour intensive, very difficult to clean and time consuming. There's a risk of cross-contamination from one ingredient to another. It's quite an inefficient process as the mixer is not always being used for mixing. Cleaning validation needs to be done, wet cleaning and drying, and then validate that that mixer is cleaned. And also the fixed mixer is generally an aggressive type of mixing action, so it's not good for certain materials. The IBC system is used in parallel process production. So each module, the filling of the IBC through sack tips, the IBC blending, feed to packing and offline cleaning are all happening in parallel. So this allows for high volume manufacturing It allows for flexibility as well as product integrity, hygiene, and different batch sizes. And also traceability can be built into the process. So using IBC blending, where the IBC is the blending vessel itself, that's loaded into the IBC, it's blended, it's unclamped and removed, so that ensures it's a closed system, so there's no risk of cross-contamination, there's no cleaning of the blender. So we're increasing the overall efficiency of the mixing process. The OEE becomes very high. So we'll just run a short video to show how the IBC blender works. Some of our recipes may need to have liquid added or have a high fat content. In this case, the IBC blender doesn't have enough work into the product to mix those thoroughly. So now we have an option for an IBC intensifier lid, which is put onto the lid of the IBC and is used in conjunction with the IBC blender to mix those products. And this high shear lid can operate up to 3000 RPM. We have the ability with the IBC blender to add in liquid and fats during the blend. These are added through a container, through a drum, and can be pumped in up to 10 litres a minute. So it's a contained addition during the blend. We use the high shear to mix the powders and the liquid together. There's no need to open the blender up and add liquid and potentially risk contamination. We'll show a video on how the liquid addition system works now. We'll look at a comparison between a fixed mixer using a sequential process and an IBC blender using a parallel process. The example we use is a sports nutrition manufacturer, but it could be any manufacturer in any industry, because this is typically what we would see. As we saw from the example, there's a lot more product that can be produced with an IBC blender used in a parallel process system rather than a fixed mixer used in a sequential process. When we add in products with allergens and they require significant time for cleaning and changeover, then it's a lot more efficient and flexible to have a parallel process. Packing feed is a critical part of the process. You need to maintain the blend homogeneity. There needs to be a control feed to the packing machine so you get consistent bulk density and you also get consistent packing weights. The feed system needs to be able to handle different flowing powders. It needs to be automated to optimize the efficiency. It needs to be a dust controlled system, and you also need complete discharge. You don't want to leave any product in the process above. Matoon's cone valve discharge technology provides many benefits when we're feeding material to a packing machine. It gives a consistent density of the product by controlling the flow, so you get consistent pack weight in the packing machine. You also don't get any powder handling problems. And it's also an automated, dust-free process. Look at a short video on a typical packing feed example now. As well as a automated cone valve discharge, Matoon also has a manual cone valve discharge, where we use a lever to raise the cone valve into the product flow, into an IBC. When we compare this to a butterfly valve system, we can discharge free-flowing powders such as sugars, salt, 3-in-1 beverages, detergents, plastic granules. But unlike the butterfly valve system that promotes core flow, so they can't prevent rat-holing, segregation, risk, and they can't discharge powder fully. And there's a dusting on the base of the butterfly valve, so it's always underneath the IBC when you close it. With the manual cone valve system, we promote mass flow, so we prevent rat-holing, segregation, we can discharge, and we have a contained powder discharge. So we'll look at two short videos, one firstly with a butterfly valve system and the core flow effect, and then a second one with a cone valve type system and the mass flow effect. This is an example of the IBC cone valve system feeding to packing, and the discharge station for that can be located on a frame above the packing machine or on the floor above. It provides a constant feed to the packing machine, as we mentioned, to maintain the density and consistency and quality of the product. This shows a B2B packing system, or a powder packer as we call it. So here we're dosing directly from the IBC into a bag or a box or a drum. Typically the packing size would be anything from 5 kilos to 25 kilos. But this is designed to be quick and easy to dismantle, change recipes and clean. In summary, the Matoon IBC cone valve technology is used to maintain blend homogeneity. It can control and discharge free-flowing powders, very sticky cohesive powders, handle fragile products, and it's a dust-free handling system. Equipment cleaning is obviously a very important part of the process. Some of the key considerations are mentioned here. Some industries, such as the dairy and infant formula, would stipulate that most cleaning processes need to be dry so they don't have a risk of bacteria growth. Whereas if you're handling allergens and flavours, then it needs to be a wet clean to ensure you get thorough cleaning and drying. You also need to consider the production capacity, how many recipe changeovers are there, the palette characteristics, and whether you need to automate the process now or in the future. And also, how does your QA team need to validate the cleaning process, whether it's a swab test or other means. As we mentioned, the IBCs themselves are cleaned offline. This is an example of a IBC cleaning system with water. So this could be manual or could be fully automated. So we're using a high pressure spray ball to lower onto the inlet of the IBC. And we've also got a number of spray nozzles around the cone valve area, which would raise and lower the cone valve during the process. So this is a validated wash cycle. So we normally rinse the IBC with water, add detergent, do a final rinse, and also do a drying cycle. As well as the water IBC cleaning system, we have a dry air cleaning system. This is particularly relevant to the dairy industry and infant formula industries, so they can't risk any contamination or bug growth with water, so they much prefer to use dry air. This uses a spray nozzle with a compressed air supply, filter supply, that lowers down onto the IBC, and any airborne dust is ejected out of the bottom of the IBC with a dust collection system. It's a fast cleaning system. Typically this would take 6 to 10 minutes to turn around a clean IBC, and it's a validated process which the QA can use. So here we show a typical process flow. This is in the beverage industry. So this could be a single floor facility or with a mezzanine or frames, showing separate sack tipping of the ingredients into an IBC through a sieve, separate process of IBC blending, feeding to packing and offline cleaning. A very good example of a parallel process efficient plant. Shows an example of a efficient gravity feed plant for an infant formula production. So on the top floor, we're separating the zones. On the top floor, we've got the raw materials handling part coming through on the left, through the low hygiene zone to the high care area, where the operators decanting the sacks into the IBCs down below in the middle floor. So in the middle floor, we've got IBC movement, we've got IBC blending, IBC discharge, and off to the side, we've got IBC washing. So we're using that as a medium care area. Then that medium care area is feeding into a high care area down below, which is the packing hall. So a very good example of separating the zones to reduce the ongoing utility cost and maintenance. This is a pharmaceutical process, so it's an efficient process flow. So we're showing 2 floors that are being used for gravity feed. And the advantage there is that the IBC as a closed system is being used on the first floor, and the GMP area, the high hygiene area, is on the ground floor. So the actual space and height is reduced, that requires a high degree of air circulation and humidity control. So on the left we have the operator loading the IBC through a dispensary. That IBC is being lifted up through to the first floor using a pillar lift. And then we're feeding the wet granulation process. We're going through wet granulation, fluid bed drying, and then we're loading the IBC from a mill. The IBC then is being taken back up to the first floor, and it's being blended in the IBC blender. Then we're discharging into different processes with dry granulation and tablet press. And then we're collecting the tablets in a tablet IBC. And the offline cleaning will be in a separate room. Now look at a case study video for a company called Vetra, which is a 3-in-1 beverage manufacturer in Malaysia. They installed a MatCon system in their existing factory. I'd just like to summarise the benefits of the Matoon IBC system and how it's used to optimise efficiency and capacity. These are split into operational benefits and also financial benefits. The operational is the parallel process increases flexibility and agility. In a lean perspective, we have a high overall equipment effectiveness of the equipment. It reduces the process flow between processes. It reduces the takt time. All the cleaning is done offline, dry cleaning or wet cleaning. Traceability and segmentation of the batches is achieved. Financial benefits can be significant. There's quick changeover time for recipes and allowing make to order rather than make to stock. This reduces the need for inventory and work in progress, improves the cash flow of the company, and the investment is modular. So as and when the production demand, you can increase the equipment. So if you've got any questions, please contact me after the webinar or email me or contact Matoon at our website details, which I'll show next. Thank you.